do some optimization. You have 180 meters of fencing with which you are going to make two congruent rectangular pastures adjacent to a river. Find the X and Y that will maximize the total area. Also, keep in mind it did not ask for the area. If it asked for the area, of course you'd have to find it. So just be careful with what it's specifically asking. In this case, once we find X and Y, we're done. Optimization normally is going to involve two equations. One of them is going to be what I know. I know how much fencing it is. I'm going to use this word very loosely, but I'm going to find the perimeter. It's not necessarily the distance around, but it is the amount of fencing that I have. So it's the amount, oops, let's get this thing to work. There we go. The amount of fencing that I have is going to be equal to a very poorly drawn picture. Y, and Y. Because I said so, because I said so, because I said so. And then two X's that live in, well, you know. Okay, so we have 180 meters of fencing, so that's 180, and that's equal to this, which is, again, similar to perimeter, but it involves some inside parts, and it doesn't include this because we're assuming we're going to make a, I think probably a cow pasture or something like that. So the cows, I seriously doubt they're going to just get in the river and like float on down. They do wade around in the river, particularly on hot days. They'll get down in the river pretty much within like a foot or two of the top of their body. It's kind of interesting. So maybe they should put a fence up here. That's not the problem though. Let's solve for a variable. You want my opinion? Good, I'm glad you asked. My opinion is we are going to have a mess. If we have to divide by 3, you're going to have some repeating decimals. Repeating decimals obviously need to be rounded. You run into rounding error. The answer is not going to be nearly as accurate. When you have inaccurate answers, you wind up with natural disasters or unnatural disasters like the Challenger explosion or bridges that collapse. So we're going to solve for X instead. 180 minus 3y all divided by 2, and that is equal to X. That's basic algebra, you know that. This is fine, but let's make it even finer. Hey, equation, you're looking mighty fine. All right, what are you doing with your fine self-equation? I'm substituting. Substituting into what, you might ask? Well, it's asking about the area. Since it's asking about the area, we need to find an equation for area. Well, this area is 2 rectangles. 2 congruent rectangles that measure X by Y. Ah, dang it. You wouldn't scroll. Okay, we're going to take this that is equal to X. We're going to plug it in right there for X. Area equals 2 of those. 90 minus 1.5 Y times Y. Hey, I have an idea. Let's distribute from both sides. 2 on this side, Y on this side. We can do 2 things at once. This is calculus, after all. 2 times 90 times Y, that's 180Y. 2 times 1.5, that's 3 times Y, so Y squared, so minus 3Y squared. When finding, this is neat, when finding when optimizing maximum or minimum, when we're finding a maximum or minimum, it is where the derivative equals 0. It's the same, whether it's a maximum or it's a minimum, the derivative is going to equal 0. We can go into some in-depth stuff called sign analysis to determine if it's a maximum or a minimum, but I will go ahead and tell you that whenever we find this, it is going to be a maximum. Matter of fact, I might get into that just for fun. 180 minus 6y is equal to 0. I'm actually going to do it just to prove a point here in a second. All right, we'll solve for y. We move the 180 over. We divide by 6. That becomes 30. Now, I'm going to pause this for a second. Let's make sure it is a maximum. Let's pull out some old stuff that you probably just did. Look familiar? 30. Let's pick a number this side of 30 and plug it into the derivative. If we plug in 0, we wind up with a positive. If we plug in a number bigger than 30, we wind up with a negative. Let me tell you what that tells us. The derivative is increasing until we get to 30. The derivative is positive until we get to 30. The derivative is negative after 30. The original function was increasing until you got to 30 and then decreasing afterwards. all that stuff that we did in the previous section, it kind of goes unsaid here, but it makes sense if you apply it. And you can see that this is truly a maximum, and in this case, not a minimum. If it was a minimum, it probably would work the same way, but now we would have opposite signs in this case. Increasing, then decreasing. So 30 truly is a maximum. Okay, just wanted to prove a point there. Now that we know y, we can very easily find x. Once we find x, we're done, because that's all it asked for. It did not ask for the area. So all we have to do is plug y in, and we'll find x. So here we go. 90 minus 1.5 times 30, and that's equal to x. Let's see, 1.5 times 30 is 45. 90 minus 45 is 45, and that is equal to x. Again, it did not ask for the area. If it did ask for the area, then all we would have to do is plug it into that formula right there, the 2xy, but it didn't ask. There we go. That's what I looked like in middle school.